In this video, we will be going over a GCSE question of the area of a shape. So, we have our question. Work out the pink area shown opposite. The three circles shown each have a diameter of 8 centimeters. So, since we know that our diameter is 8 centimeters, we can find out that the radius of each of our circles is 4 centimeters. And so we can label that on our diagram. And the shape can be split up into three distinct areas. So we have the rectangles, the sectors of the circles, and an equilateral triangle. So the area that we're going to find first is the area of the rectangles. So to start off, we're going to label the sides on one of our rectangles here that has been shaded in. So the longest side we have as 8 centimeters, which is the length of 2 radii, and our shorter side is 4 centimeters, which is the length of 1 radius. And so for the area of a rectangle, we have our equation for area as base times height. And if we substitute our values, so our base can be 4 centimeters and our height can be 8. And so we have 4 times 8 is equal to 32. Now, there are 3 rectangles here. So what we can do is we can multiply 32 by 3. And so this gives us 96 centimeters squared. And so this is our first part of the areas. Now we're going to move on to the sectors of our circle. And so to find the area of one of these sectors, we take a fraction of the area of a circle. So an area of the circle would be pi r squared, and the area of our sector would be theta over 36 times pi r squared. And so to find out the angle in our sector, we have the internal angles of our rectangles being 90 degrees, and we have 2 of those. So we have 90 times 2. And we have the angle of our equilateral triangle here at 60. And so if we add these together, we get 2 times 90 plus 60. And we subtract that from 360. And this gives us the value of 120. So 120 degrees is our value for theta. So we can substitute that into our equation here, along with our radius having the length 4. So we have 120 over 360 times pi times 4 squared. And so this should give us 16 over 3 pi. So we'll stick with fractions to make life easier for ourselves further down the road. And there are 3 of these sectors of the circle. So we multiply 16 pi over 3 by 3, and this gives us 16 pi. Now, the final area that we have to calculate in our shape is the area of our equilateral triangle. So we have our equation for the area of a triangle, which is half AB sine C. And so what we can do here is we have all of our angles at 60 degrees. So that's our value for C. And the lengths of the side of an equilateral triangle are all the same. So we have that as the length of 2 radii, which is 8 centimeters for each side of the triangle. So if we substitute that into our equation, half times 8 times 8 times sine 60. And if we put that into our calculator, we get the value of 16 root 3 centimeters squared. And this is our third area. So what we can do now is to find the total area of our shape. We add the 3 areas that we have calculated. So we have the area of our rectangles, which is 96 centimeters squared. We have our area of our sectors, which gives us 16 pi, so plus 16 pi. And we have the area of our equilateral triangle here, which is 16 root 3. So if we plug all these values into our calculator, we will get the total area as 174 centimeters squared. This is to 3 significant figures. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.